what we're going to be looking at here is if you're given an equation and it has brackets and you're asked to solve it, is what we're really trying to look at. So, for example, let's just make up a question. If I've got 4 lots of a number, and let's say that number's 2. 2 plus 3, what will that equal? Well, you'd have to do big maths. 2 plus 3 is 5, times by 4 is 20. So that's going to equal 20. So we know x has to be 2. Like it can't be 3 because 3 times 3 is 6. 6 times 4 is 24. But how do you solve this? Well, there's a couple of ways you could go about doing this. This is saying I've got 4 lots of a number plus 3 equals 20. Well, if you've got 4 lots of a number, 4 lots of this number, and that is to equal 20, the first thing we can do is divide by 4 because we've got 4 lots of a number plus 3. So a number plus 3, you've got 4 lots of those. So if you want to look at it, you've almost got like a number plus 3, you've got another number plus 3, you've got another number plus 3, and you've got another number plus 3. And all of this equals to 20. So you've got 4 of those. And we just write it like that. So the first thing I want to do would be easiest is, well, what's just a number plus 3? What would that be equal to? Well, if I've got 4 of them that equal 20, wouldn't it be fair enough to split this 20 up evenly into each of these? So you'd have 5, 10, 15, 20. So that would equal 5. So like 4 lots of a number plus 3 equals 20. It doesn't mean one lot would have to equal 5 because we've got to split it. So what we've actually done there mathematically is we've actually divided both sides of the equation by 4. That's what we do mathematically. And that leaves us with x plus 3 equals 5. Now we're just left with x plus 3 equals 5. So all we need to do now is just minus 3 on both sides. So I've got something plus 3 equals 5, so I'm going to take 3 away from both sides. And that gives us our answer of x equals 2. We can substitute this back in now. 2 plus 3 is 5. 5 times 4 is 20. Now that's one way to go about it. Another way to go about it is go, well, instead of splitting it up by 4 first, if I've really got 4 lots of this, don't I actually have 4 lots of x? And I've also got 4 lots of 3. So if I had 4 lots of x, that would, be 4x. And if I've got 4 lots of 3, wouldn't that be 3, 6, 9, 12? That would be 12. And that equals 20. So now I can minus 12 from both sides. 4x equals 8. And now I can divide by 4 from both sides. I've got 4 x's, so 1x would be 2. So either way, what we did here is we actually expanded it. So when you expand it, all we're doing is just multiplying the 4 times the x gives us 4x, and 4 times 3 gives us 12. So we actually expand those, and you can expand it like that. That's a pretty common way for people to show it. You can show it as an array method as well. But basically you've got 4 lots of whatever's in here. So I've got 4 lots of x and 4 lots of 3. That's why you multiply it. So that's how we can solve these equations and really look at those. So we'll just choose a couple ones out of here, and we'll just have a look at how that works. So I might choose this one here. So we've got another thing. Let's just, before we move on to that one, we'll just look at the negatives and how that works. So if I've got, for example, let's go with, I've got 5 lots of a number, and let's take away 3. And let's give this number 10. 10 minus 3 would be 7. 5 times 7 would be 35. So really, if you wanted to build up this equation, you think about what's happening. It's got 5 lots of x and 5 lots of 3. So you could expand it first. You've got 5x minus 15. So I've got 5 x's and I've got 5 negative 3s. 5 negative 3s will give me negative 15. Now what I can do is I can just add 15 to both sides because it's take away 15. So I want to kind of make that equal 0. Thanks, Sophia, for that one. You just really want to get it to 0. So to get that to 0, I've got to add 15. But if I do it to this side, add 15, I've got to add 15 to this side. So it's going to leave me with just 5x, and that will leave me with 50. Now I want to divide by 5 by both sides because I want to split this into 5. So I've got to split this into 5. It's going to leave me with x equals 10. Alternatively, you can do that another way. We've got 5 lots of x minus 3 equals 35. I can actually divide by 5. Now 5 and 35 go really well, so I can divide. If 5 and 35 didn't go well, I'll probably expand first, okay, and then solve. But this way I can divide, because it doesn't give me a fraction. So I'm going to split everything into 5, just to start off with. If I split this into 5, I'm just going to be left with one group of x minus 3. And split the 35 up to 5 will leave me 7. Now I can add 3 to both sides. So I want to get rid of the negative 3. I want it to equate to 0. And that means with x equals 10. We can substitute these in. X equals 10. 10 minus 3 is 7. 5 times 7 is 35. So dealing with negatives when we expand, note that happens. What happens there? Okay, let's look at this question here. 4k squared. For k minus 2 equals 3 2k minus 6. Oh, this is tricky. What are we going to do here? Well, can we divide by 4 on both sides? If we do that, we're going to end up with 3/4 on this side. If we divide by 3, we'll end up with 1 here, but we're going to end up with 4/3 on this side. So I probably wouldn't divide. Let's expand then. So this would be a case where I would expand. That's going to give me 4 lots of k, give me 4 lots of negative 2, so I just multiply here. Positive times a negative will give me negative 8. 3 lots of 2k would give me 6k. 3 lots of negative 6, negative 18. Now we're similar to the other subchapter where we want to try and get all the letters on one side and all numbers on the other. I'm going to move the 4k over here. So I know I'm going to have to minus 4k. And it's going to be easy to minus off 6k because it's going to leave it positive, right? So I'm going to minus 4k. 4k minus 4k on both sides. So I've kept it balanced because I've just minus 4k on both sides. That'll leave me negative 8. I'm left with 0k here. That'll leave me 2k. Now I'm going to add 18 to both sides because I want to get rid of that. That's going to give me 10. So remember, negative 8 to 0 would get me 8. I'd have 10 left over. And that's going to leave me to 2k. Now I've just got to split the k into 2 and divide these by 2. And that would leave me with, therefore, k equals 5. So in this case, you'd have to expand first. That would be easiest. Otherwise, it's going to get really, really tricky. It will still work, but you're going to end up with sort of fractions and it will get a bit more difficult. So I'm just going to go through and point out a few of these questions. Here, you could divide by 4 first. 12 divided by 4 will give you 3. Or you could expand it. 4p plus 4 equals 12 and solve it. Here's a bit different. If you expand this with a negative, it's going to give you negative 20p minus 30. You could divide by negative 10, which would leave that with 2q plus 3. That would be positive. Negative 9 divided by negative 10 will give you 9. So I'll probably divide by negative 10 in that case. This one's a bit tricky. Let's have a look at this one. Okay, if I want to divide by 3 first, I would actually need to divide it by every term. So that would be 2x minus 1 on 3, which would cancel that out, plus 5x on 3 equals 52 on 3. I don't think that goes with each other. It doesn't, because 30, and then I'm left with 22. 22 doesn't go into 3. So here you're left with these fractions, but notice you're dividing each of these terms by 3. So I probably wouldn't divide by 3 to start off with. I would expand. So if you do that mistake and you find, oh, actually that's not really working, it's not good. What I want to prove there is that you need to divide every term by 3. So let's expand it instead. We'll expand this. That's going to give me 6x minus 3 plus 5x equals 52. That's going to give me 11x minus 3. I've just added these two together, equals 52. Now I just add 3 to both sides, 11x equals 55. And now I can divide by 11, x equals 5. Ryan, have a look at you want to do the right-hand compressed list on there of those questions. Yeah, for that one, yeah. Yeah, and that's it. If you've done that, you can go on with the next one. If you've done that, then if you can start doing the quizzes of 8A, B, C, and D, that'd be good. All right, so that's pretty much where we're going with this, guys. So I'll let you try and have a work through that. So sometimes you want to expand. Sometimes you may want to divide. Like here, you could divide by the 2 straight away. You could expand as well. Here you could divide by 3 because 3 goes nice into 15, 5 goes nice into 4. So just be careful. But if you do have alternate terms, it does get a bit tricky. So stuff like this, if you divided by 4 straight away, you'd be left with 5/4, 5w on 4, which isn't good. So you'd want to expand, collect like terms, and then solve the other way. When there's 2 on both sides, just expand both of them. For this one, for example, 5f2, I'm just going to write this one down. So this one's a good example of where it would be a lot easier to divide. 5f minus 2. I mean, it doesn't matter too much. It's not too more difficult. So I'll just show you this one. So here you could expand first, right? Which would be 25f minus 10 equals 15f plus 20. Minus 15f on both sides, you'll be left with 10f minus 10 equals 20. Add 10 to both sides, 10f equals 30. Divide by 10 on both sides, f equals 3. But alternatively, what we could have done to start off with is we could have divided by 5 on both sides. If you divide by 5 on both sides, because 5 goes into 5 and 5 goes into 5, it wouldn't have mattered, like if this number was 5, 10, 15, 20, or whatever. If you divide both of these by 5, you're going to eliminate that 5 straight away. And then you're just going to be left with 5f minus 2 equals 3f plus 4. Just lower numbers to work with. Now you can minus 3f on both sides, which would leave you with 2f minus 2 equals 4. And then you can add 2 to both sides. F equals 6. Sorry, 2f equals 6. Divide by 2 on both sides. F equals 3. So that's a case of where you could divide by 5 on both sides. So here you could divide both sides by 2 just to get rid of that. Or you could expand. I'm just giving you guys a bit of flexibility with those. This one you could divide by 4 on both sides. This one here you could divide by 2 on both sides. It'd probably be a bit easier. Here you probably wouldn't divide because 3 doesn't go into 11. So you would expand here. Here, I wouldn't divide by 2 on both sides. I mean, you could. That would change this to just 3 plus 5r. That would change that to 3. That would change that to 2 lots of this, and that would change it to 3. But you could expand. So sometimes if all the terms have a common multiple, you could divide by them. Not multiple, a common factor. So here 3, 18, 3 doesn't go into 4, so you wouldn't divide by 3. Here 2 doesn't go into 3 or 5, so you can't do that. Here you've got 3, 3, 3, and 15. So here you could divide by 3, which would be a bit easier, rather than expanding everything out, because it'd be like 3 times 4. It just takes a lot more. So depending on the question, sometimes you expand, sometimes you can divide first. Most teachers would just show you to expand, collect like terms, and then add and subtract on both sides. I don't like to do that because I like to be a bit more flexible with it. And yeah, just think you got to be a bit more flexible with it. So have a go at some of those questions. If you need to finish off the other exercise, please do. I hope that helps and gives you a bit of flexibility and a bit of understanding. So